Hi, 6th grade. Today we are going to be talking about gases. So we are going to be reading in our book on page 305. Now, by now you should be kind of getting the gist of the information that we're looking for. So right now, kind of whisper to yourself, what do you think you're going to be reading about? You should be thinking we're going to be looking at, does it have a definite shape and a definite volume? Or is it indefinite shape, indefinite volume, or a mixture of the two? You should also be thinking to yourself, how are the particles arranged? How are the particles acting in a gas? So let's go ahead and preview some of our text features in order to see what we're going to be reading about. How do you describe a gas? Okay, volume, so we're going to be kind of reviewing volume a little bit. I can see that there's another one of these boxes. Some of you have chosen to do these boxes in your book. This is really good practice for you. And now, we're talking about pressure here, and we're not even going to go on to this page, and we're also not going to talk about temperature. We'll talk about temperature actually in our next section, so we're going to hold off on this. So we just have this one page to read. How do you describe a gas? Like a liquid, a gas is a fluid. Unlike a liquid, however, a gas has neither a definite shape nor a definite volume. If a gas is in a closed container such as a flask in figure 5, the gas particles will move and spread apart as they fill the container. So what we're looking at here, here's this flask, and this is a gas, and it's taking the shape of its container, and those gas particles spread out so it fills up the container the entire time. So we can go ahead and stop right now. That should have been a big, huge kind of flasher going off in your head. We need to add how to describe the gas. So a gas or gases have indefinite shapes and they have indefinite volumes. Now, I want some of you to actually stop right now and say the word definite. Definite, not density, not defiant, definite. What definite means, I don't know that I made it clear enough in the earlier videos. Definite means that the shape won't change. So when we put the prefix in front of the word definite, it means that it's not definite. So the shape will change. The shape is not a definite shape. And the volume for a gas is not a definite volume. So the volume is going to change, the amount of space it takes up. It takes up however much space we allow the gas to take up. So let's go back to our reading. If you could see the particles that make up a gas, you would see them moving in all directions. As gas particles move, they spread apart, filling all the space available. Thus, a gas has neither definite shape nor definite volume. When working with a gas, it is important to know its volume, temperature, and pressure. So what exactly do those measurements mean? And we don't need to worry about pressure. You'll learn about that up in high school. We'll talk about temperature a little bit later, and you already know about volume. So let's add that key phrase here is gas particles move. Okay, so they spread apart. They fill all available space. And one piece of information that they leave out here, you can kind of tell by the trails leaving behind, they're moving the fastest of the 3 states of liquid. So arrangement of particles. Spread out. How they spread apart, filling all available spaces. And they move very fast. Just to give you an idea of how fast they do move, I'm going to come over here to this last paragraph. At room temperature, the average speed of particles in a gas is very fast. At about 20 degrees Celsius, the particles in a typical gas travel about 500 meters per second. That's more than twice the cruising speed of a jet plane. 500 meters per second. So more than twice the cruising speed of a jet plane. Think of how fast a jet plane is. That is insane. And the particles, that's just in a regular room. That's not even if we get them really, really hot. They'll move even faster. So the only other thing that I want to show you, it doesn't give you a very good idea of how fast the particles are moving, and this is much slower, but I wanted to give you, you could see that the particles of a gas moving. So here's just a balloon, and so when you zoom in, compared to what the liquid and the solid looked like, you could see that the gases are moving, the particles are more spread out and definitely faster. The only other thing that I definitely want to talk about too is now kind of comparing solids, liquids, and gases. One of your I CAN statements is being able to compare and contrast the three. So just here kind of reviewing, the molecules shown are from three different substances that are all at room temperature. In the solid, molecules are strongly attracted to one another. They vibrate but do not move past one another. And molecules stay in fixed positions because of their strong attractions for one another. A solid has a definite volume and a definite shape. So there's what we have going on with a solid. In the liquid, molecules are attracted to one another. Molecules vibrate but are also able to move past one another. A liquid has a definite volume but does not have a definite shape. And the liquid doesn't have a definite shape because those particles are able to move out of their fixed positions. So since they can move, when they don't have a container holding them in place, they're going to spread out and move. And then third, we have a gas. In the gas, molecules are not attracted to each other much at all. The molecules in gas vibrate and are also able to move freely past each other. A gas does not have a definite shape or volume. Gas molecules will spread out evenly to fill any container. So this one here, they're not really attracted to each other. So that's why the liquid, the molecules will still stay somewhat close to one another when you spill. That's why you kind of get a puddle of a spill, because there's still some attraction between those molecules. So they might spread out a little bit, but they're still going to be close together and moving slowly. It's not until we get the gas that they break those attractions and they are just going all over the place at high speeds. So this is what we now know about solids, liquids, and gases. You are free to move on to your next step.